said, I'm excited to be teaching the workshop, and I'm excited that each of you sort of signed in and joined us this afternoon. Obviously, I think all of you read a little bit about the description about what we're going to be covering today. As a show of hands, has there been, I mean, and again, I don't have the whole video and stuff out, and again, I prefer sort of in person, but has anyone used Hops or Compute or Grasshopper Player at all? Or I'm just trying to get a show of hands as to what our experience level is. Looks like maybe a couple people have used it. It's totally fine if you haven't. We're going to kind of start from the beginning, and I'll do my very best to try to explain everything as clearly as possible. But if there are any questions at any point that something might not make sense, or I'm going too fast, please just tell me to stop, or post something in the chat or Slack channel, or even just unmute yourself and ask your question. It's totally fine, and I'm happy to try to go over and answer any and all questions. And so obviously today we're going to be covering Hops and Rhino Compute and the Grasshopper Player, which, put a different way, is really just what are all of the different ways you can use a Grasshopper definition, right? And if we think about this, if we want to be really concise about what we're talking about, it's really what are the different ways that you can use or call a function, right? A function, if we think about it from a programming perspective, is really just a module of code that takes in some data, processes it, and returns a result, right? And if we think about a Grasshopper definition, that's exactly what that is, right? We usually have some sort of parameters which allow us to pass data in, or some sort of parameters that we want to use to control some geometry. It does something, and then we get the resultant geometry back, right? So we can think of Grasshopper in its basic state as a function. The same idea as a function in coding. And so these are really the different ways that you can currently use, or the current ways you can use a Grasshopper definition. The most basic is probably what you've all been doing or have done in the past, which is to do it in desktop mode, essentially just running everything on your screen, passing everything through the graph, and then getting some results back. We can also call the definition or create a definition and use it using the Grasshopper Player, and that is compatible both in Windows and Mac OS. Or we could call the definition or the function using Hops and Rhino Compute, which is running on a local server, which we'll talk about more in a little bit. It is important to note that that particular method is really only supported on Windows because Rhino Compute uses Rhino inside, and that is really only compiled for Windows currently. Another way is you could call the Hops definition on a remote server. So if you've got a remote server running somewhere, as long as that remote server is a Windows-based machine running Rhino Compute, you can call the definition from Windows, Mac OS, a web, a phone, any other application, anything that can send HTTP requests. And lastly, you can compile a definition as a plugin via the script compiler. And so what we're really going to be talking about today primarily are these four. We may show briefly number 4. We're not going to really talk about in great detail how to set up a remote server, but we do have guides on that. If you are interested in that particular topic, we have some guides that walk you through setting up a remote server so that you can hit that endpoint. Again, some of this may not make a whole lot of sense just yet, but I'm hoping by the end of the day, all of these terms like remote server and what all of those things mean will make a whole lot more sense. So again, you may or may not, but hopefully you ask yourself, why do you even really want to do any of this when you were signing up? And really one of the primary objectives that we're talking about today is we're hoping to share different methods with you to be able to share with Grasshopper documents or functions, if you will, with your other colleagues, right? Being able to share functions that you can reuse over and over in your definitions is, I think, a pretty powerful way to begin prototyping at a larger scale, right? If you're working with collaborators and being able to create definitions or functions that can be reused, this is a way to actually start to scale up some of your projects. It also lets you simplify complex definitions, right? And we'll talk about that in more detail, but lets you take these large sort of spaghetti code that you may or may not have generated in the past and simplify it into more discrete components and hopefully make that easier to read. It lets you solve your Grasshopper definitions. In some cases, can solve these in parallel. So if you have certain projects or simulations that are very long running, and currently Grasshopper 1 is single threaded, right? So you really don't have the ability to run different simulations in parallel. Now, using Rhino Compute, in addition with hops, you can actually begin to solve some of these definitions in parallel and hopefully speed up these large calculations. It also lets you call Grasshopper or solve Grasshopper definitions asynchronously. If you've created a big definition in the past, you may have noticed that changing one parameter might take 5 seconds, 10 seconds, hopefully not longer than that, but you may have run into some really large definitions that take a really long time to process. And when you do that, your Grasshopper graph sort of locks up, right? The UI locks up and your computer's kind of unusable until it returns the result. And with hops, we can specify whether we want to make that call asynchronous, which means it doesn't lock up the UI thread and sends the request over to the server, which is doing its calculation, and doesn't lock up the UI while it's waiting for the results to come back. So that's another benefit of using some of these methods. So we're going to cover all of that in greater detail as we begin to talk about those different topics like Grasshopper Player, hops, and Rhino Compute. So a little bit about me. I'm a developer at McNeil & Associates. I live in South Carolina. I have a doctoral degree from Harvard and a master's degree of architecture from Columbia. I'm a licensed architect. So I'm coming to the field from an architect's perspective, but have now sort of moved away from, say, traditional architecture role into more of a developer role. Yeah, hopefully that background allows me to kind of see both sides of the fence, right? And understand what are some of the pitfalls that architects or designers or, architects or designers are running into, and how we can sort of improve that workflow. So today's workshop, we're going to talk a little bit about our introduction and what the Grasshopper Player is, and we're going to go through some demos and things like that. And hopefully that'll take about an hour total. And then we're going to have a short break. This may or may not be 15 minutes. It'll probably be shorter than that. But we'll have a short break. And then after the break, we will start to cover hops and Rhino Compute in greater detail, and then finally cover the script compiler. Hopefully that'll take about 3 hours. There's a chance it might go a little long, but I'm hoping to try to keep this to about 3 hours. Before we jump into the next section, are there any quick questions about the workshop today? No? Okay. Again, feel free to just unmute and ask your question or stop me if at any point something doesn't make sense. So today, we're going to be talking about the different ways that you can use a Grasshopper definition. And to me, I like to think about that a little bit the way a developer looks at things, which is to think about it as a function. A function is sort of this reusable part of code that you can call over and over again, right? And we sort of defined it earlier, which is this code which has some inputs and an output and does some sort of action in between. And typically, we're not really going to get into a lot of text-based coding today, so don't worry about that. But I would like to kind of show you like the way a developer would look at a function, or the way we think about a function in most languages. We'll have some variation on this syntax, which is to say, usually a function has a name, a unique name of some sort. It's going to have the output type. So from this particular function, what is the data type that we're going to be returning? Is it an integer, a number, a string, which is just text? So what is the type of data that you're returning? And then it also has the inputs. So inside those parentheses can be any number of arguments that get passed in, which are what we use as the inputs to the function. Inside the brackets, the curly brackets, are the instructions of the function, right? Those can be any length. Typically, you try to keep them fairly concise, but it can be any length for a function which is running through these instructions and performing certain actions. And then finally, we have the return of the function, which is going to return whatever it is that we're trying to return, right? The return type. And so if we look at a quick example of a function, we should be able to very quickly, just from this brief introduction to functions, be able to read something like this, right? We know that the function's name is called find maximum, and it's going to be returning an integer, right? The int is short for integer. So we know that whatever is coming out of this function is going to be of a type called integer. It's passing in, when you call this function, you're going to pass two numbers that are both integers as well, right? So num1 and num2 are both types of integers. And then if we look at inside the curly brackets, it just says, if num1 is greater than num2, then we return num1, else we're going to return num2. And that's all that function does, is try to find the larger of the two numbers, right? So fairly simple, but with that short introduction, we should have a way to begin to understand how a simple function like this would work. With Grasshopper, we can do the same things, right? We can create our own functions in Grasshopper, but we have a certain set of components that we want to use to be able to to define what is an input and or an output, right? We have to have certain, it's not going to know every type of component that we pass in, or every function that we create, won't know how to determine what is an input or an output unless we use a certain set of components, which we call the contextual components. It just means contextual components in this use means that there's components that change their behavior depending on where you're using them, right? So if you're using them inside a definition that you're going to call with the Grasshopper player, these components will act in a certain way. Or if you use them with hops, they might act in a slightly different way. They're still pretty basic. They all still do more or less the same thing, depending on where you call them. They're just a slightly different in how you use them. And that's why they're called contextual components. But those first two, you see context bake and context print. Those are the first two that are really our outputs. And we're going to talk more about this in a few minutes, but those are our outputs, and all the rest of them are inputs. You see they have get. And so those are our get components, or those are when we define our function, will be used to tell our function, these are going to be our input values, right? So let's just take a look at one of those inputs. For example, we can use the get integer. And when we do that, you can see at the very top, we're going to see something that says the name of the component. And again, because this is a contextual component, it behaves differently depending on whether you're using it for hops or with the Grasshopper player. So with the Grasshopper player, the name isn't all that important, but the name for hops is important, because this name is what will end up being used, or this name is what is used for the parameter name when you create a hops definition. Again, this will all make a little bit more sense when we start to actually do these examples. But so there's a name, We have a prompt. Now, when we use the Grasshopper Player, the prompt is important because the prompt is something that you can type in a message to your user, whoever is using the Grasshopper Player. And this is what will show up in the command line. So I should probably go back a step and just say, you know, if you've never used the Grasshopper Player before, the Grasshopper Player is a way to essentially call a Grasshopper or load a Grasshopper definition through the command line. So it hides the entire Grasshopper graph, right? And it lets you load and visualize a Grasshopper definition without having a user who has to open the visual graph and change sliders, right? So you or I may know someone who isn't comfortable opening Grasshopper and loading some huge definition and trying to figure out what slider they need to change. Well, with the Grasshopper Player, you can set up a couple inputs that you want your this user to modify to change whatever it is that your function is doing. Let's say you're creating a tower and you have a couple parameters for your tower and you want to create some different options. You could create a Grasshopper file that you could send to someone, and just using the Grasshopper Player, they don't have to open up Grasshopper at all. They can simply load it through the command line, and then they will get presented a number of prompts. In this case, like the number of panels, what are the number of panels you want to use, what's the height you want to use. It can be defined in any number of ways. And then they actually can generate, you know, geometry from that, right? And so we'll show how that works. But that's basically the way the Grasshopper Player works. It's a way to call a Grasshopper definition behind the scenes and only present information to the user through the command line. And so for some users, that can be pretty useful. So we have the prompt. You can also specify a minimum number of values or the maximum number of values. So again, when you're creating a definition in the Grasshopper Player or even in Hops, these two values are determining how many values do you want the user to enter, whether it's on the command line, right? Are you passing 5 numbers in? Do you need 5 numbers to be able to perform your operation? Or in Hops, anything above 1 would indicate that this parameter is going to be a list, right? You're expecting a list to be coming in. If you set the at most value to 1, which is the default, then it's going to treat this parameter as an item, right? Item access. So these sort of tell the context, if you will, how many values you're going to be passing in to this particular input. And again, with this particular menu item, you can set whether it's going to have tree access. Again, for the Grasshopper Player, that's not so critical, but for Hops, you might be creating a definition where you expect to be passing in a data tree. And then it will assume that whatever's coming in is going to take the entire list and then perform the operation. Lastly, a couple components like the number components, integer or number, have parameters like a minimum and maximum, which let you clamp the input value. So you'll get a message that says, you know, if someone inputs a value that's below or above the minimum or maximum value, get some information about that, as well as presets. So the string or the integer or the number have preset values. Again, if you think about that command line prompt, a lot of Rhino commands have options. You've probably run things where you see options on the command line. You can define those here and that allow your user to just have a select set of preset values. So if you had, for example, the number of panels and you wanted 5, 10, and 20 as options for your user, you could create those preset values here and then present that to the user. So it would say number of panels and then give them 3 options of 5, 10, and 20. And so that's another way. So thinking about that same example that we looked at just a minute ago about finding the maximum between 2 numbers, we should be able to now understand, having looked at what we just talked about, that we have a visual function here where on the left side, you see we have 2 get integer components, which are the ones we just talked about. And you can also see that on the left side of those get integer components are values that I'm passing in. They have a grip, an input grip on the left side of the parameter, which lets it take in a value. When you do that, that sets a default value for that parameter, right? So for example, num1 will have a default value of 5 and num2 will have a default value of 10, right? If you leave it empty, there will be no default value. The other nice thing about having this in your definition with a predefined value is that now that 5 will flow through the rest of your graph, and you, as you're prototyping, you can begin to see what does 5, give me in my function. If this is giving me the number of floors, you'd see 5 floors or 10 floors. If it's empty, that number parameter becomes empty, and thus the rest of your graph won't be solved because you have an empty parameter, right? So that's another reason why it's kind of useful to pass some values into the left or the input side of these parameters. But then we're passing, sorry, I'm missing some slides. So here you can actually see that we talked about the context getters, we have the default value, we have the part of the function that does something, right? And this doesn't have to just be a single component. We can in this particular case because there's a component that does the maximum, finds the maximum between two numbers. But this could be any number of components long, right? This is the body of your function. And then you have a return value. And those are those two components that I talked about, which is the context print or the context bake component. Really, the only difference, they're pretty interchangeable. The only main difference is that when you use the context print, it's sort of expecting text. In some way, it could be a number, but it's converted to a text. Whereas the context bake is usually more used for geometry. And again, they have different ways when you use them in hops or with the Grasshopper Player. So when you use it with the Grasshopper Player, when you use the context print, which is what this one is, a little modal dialog will show up with whatever text you're passing into it. Whereas if you use the context bake, it will simply bake the geometry into the scene, right? And so there's two different ways of using those two outputs, but essentially this allows us to return something from our function. So let's look at a quick demo or a quick example of how we can use the Grasshopper Player. Are there any questions so far? So if you haven't already done so, I would encourage you, hopefully everyone got the email that I mentioned earlier, but I would go ahead and install hops. This is going to be important for later, as we're not talking about hops right now. But you could go ahead and install, we type in the package manager in the command line. And then if you haven't already installed hops, I would go ahead and recommend installing it. Also, hopefully everyone has an up-to-date version of Rhino. And if you go to update and statistics, you should be able to see which service release you are on. I tend to like service release candidate because those are the newer releases. They may be a little bit less stable, but in general, because we're using Rhino 7, it's not really anything that is, in this case, everything that's going into Rhino 7, at least at this point, is fairly stable, right? All the new development that may be considered less stable is all that 8.0 work. So I would look for the update frequency for the service release candidate, and hopefully you'll make sure you're on one of the latest service releases. And the reason why I mentioned that is once we launch Grasshopper, you will have the latest contextual Git components. So under params util, this is where we find all of our contextual components, right, that I was just talking about. And as we've been developing hops and compute and the Grasshopper Player, we've made changes to some of these components. And that's why I taught a workshop recently where someone didn't have the tree access, right? Because that was added, I guess, to a service release that was later than when they had recently updated. And so if you do have the latest service release, you should have all of the same user interface that I am using. I believe I'm on 7.23 in this particular instance. But so if we go under the param utility tab, we can quickly create a function like we just did by using, let's go ahead and add a get integer component onto our canvas. And if we do that, you can see we can right click on it, and those are all of our parameter or the attributes of this parameter that we can control. So again, if you want to name this, you could call this num1. Let's say I want, I right click and set the prompt. So in this case, this is what is going to be presented to the user on the command line. So you can type in anything you want, but I'm going to type in, say, set the value of number 1 and click OK. And then I can also set a minimum and maximum value. I don't have to. I'll just go ahead and set a minimum of 0 and leave maximum to whatever we want. And again, the at least and at most are set to 1, so I don't really need to worry about those in this particular case. I can hit Control-C and Control-B to copy this. And now I need to just make sure that I change this to num2 and also set the prompt to be num2, right? So they're pretty identical. It's just that the prompt is slightly different. And again, if you want to create a numeric input to this, it can be whatever value you want. This can be a slider, it can be a text panel. It doesn't really matter, but you can pass in some value here to be able to see what it is that we're working with, right? This would be our default value. So far, everything's fairly straightforward. I'm going to double click and search for the maximum components, pass that in, and then we'll use our context print component to be able to see what's coming out when we do this. Now, I would recommend going ahead and saving this document to, sorry, before I do that, you can also look at, the result, right? So I can look at the string value that is going into the text input. You can shorten this by doing that. But you can now look and see, is the definition performing the way I expect it to, right? In this case, 10 is larger than 7, so it looks like it's working. So I'm going to go ahead and hit save, and I'll save this to the desktop. So we'll say this find maximum. And now we can close Grasshopper down completely, right? We have created our function. We don't need it to be open at this point in time. The way we can call the Grasshopper Player is we can either go to Tools, Grasshopper Player, or you can just start typing Grasshopper in the command line. And when you do, you'll start to get a list of commands that can be run. And in there, you will see one that says Grasshopper Player. And as soon as you click on that, you're going to be presented with a open file dialog. In this case, it's asking what is the Grasshopper definition you want to load. I'll select find maximum. And now you can see, here's my prompt. So it's asking me for what is the value of number 1, right? I can say 15. What is the value of number 2? Let's say 6. And now the result you can see is results of find maximum is 15. So that is when we use the context print component, that tells the Grasshopper Player, hey, this needs to open this dialog and put in whatever it is I'm passing into it, right? In this case, it's the number 15, but it could be any long number of text or string or whatever, right? So that's really the simplest way of looking at the Grasshopper Player. But there's all sorts of things we can start to look at in greater detail. So I'm going to open up Grasshopper again, and I'm going to open the workshop files that we were looking at. Hopefully each of you have downloaded. And I'm going to open up the quad panel base file. And when you do, you can see that this is probably, I'm going to try to show how you might take an existing Grasshopper definition and convert it into a function that could be called in the Grasshopper Player, right? So here, what we see is we have, just a relatively simple Grasshopper graph, which has some input parameters, right? I have one, what I have here is a little module down here that I can control the size of, right? This is controlling the square, the size of that square that you're seeing. It's controlling the opening, which in this case is just 2 points that are being rotated or found on that ellipse. So there's an ellipse here, and I'm essentially finding the t value on that ellipse and then finding the other side of that. I can change the height of that ellipse and the tilt of the ellipse, right? So how much is it tilting along the normal of that ellipse, essentially. And so from there, I can then create 4 panels, 4 triangles, essentially. And so that gives me my module, and then I can array that up here using these 2 sliders, which are the num-x, the number of panels in the x-axis and the number of panels in the y-axis, right? So fairly simple, but what we need to do is essentially take all of these slider values and convert those to numeric inputs for the Grasshopper player, right? So we'll just quickly do what we were just looking at. Instead of the get integer component, which we just looked at, now we know this is a double number, right? It has a decimal. So we need to pass in a get number component. So I'll just pass this into here, and I can give this a name called size. And again, I'll right click and look at the prompt and say set the size of the panels and click OK. Again, the rest is all going to be set default values because we're just going to be passing in a single value. So now I just need to replace all of the places where this value is going. All the green wires have to be replaced with this new output, right? So I can pass those and into there, right? So it's all fairly straightforward from here. We're essentially doing the same thing over and over. Here we have opening, which is our t value. You can name these whatever you want. But basically this is going into there as well as the t value here. Sorry, I apologize. My dog is in the background whining. Hopefully she won't bark or anything, but we'll see. So we can also give it a prompt value, which is asked what is the t value. In this case, we could set a minimum and a maximum to be 0 and a max of 0.5, because I know that's the limit that I want to allow for this particular t value. And then we can continue on again with our get number. We'll say height. We'll set the prompt to height of the ellipse. And again, we just have to replace all of the places where that value is going with the output of this parameter. And lastly, we're going to look at another get number, and this is going to be tilt. Are there any questions so far about how this is working? We're going to show some more advanced examples as well.
Cool. Yeah, we had a question in the chat regarding the Google Drive, but it's in like someone, Hisham posted a link there with the files. So I guess that's the solution to that.
Yeah, up above in where I basically copied the email, you should have a link in there that shows where the workshop files are. Let me see if I can link again to that.
I think we just got it in the chat.
Okay, great.
Thanks.
Yeah, just let me know if there are any other questions like that. Here, we're going to do the get integer because now we're passing in like an integer value. So we'll say x, and we can say number of panels in the x-axis. And we're going to just, it goes into the C. And finally, lastly, we're going to go into get integer, all this y. Set number of panels in the y-axis. So I think there might be. I don't think where this is coming up. This is showing up. Well, so that's how you set up your function inputs. And I'm going to go ahead and open up the finished version of this. So you should have all of these examples. So we just looked at the GH player base, and the finished one is this exact same thing, right? It's just a little bit cleaned up. But the only difference here is that I have done one other thing, which is to take the output, right? If I look at the output, in this case, this is the output. I've essentially taken our quad panel. If I turn, or right here, I'm calling this the quad panel, but there's 4 panels here. And I've got an array of planes. If I turn this on, right? So there's my array of planes. And then from there, I'm essentially just orienting this quad panel module along each of those planes. So the geometry that I want to bake at the end of this is what I will be passing into this context bake component, right? So here you just pass in a context bake, right? If you can give it a name, and that's really all you have to do. There's nothing special about that. This is just telling the Grasshopper player, this is the geometry that when you're done with all of the different inputs, this is the geometry that I want to output from this function, right? So again, I will close this and close the base as well. And we can actually close Grasshopper altogether if you want. But here, now we can go and load the Grasshopper Player again, right? So you can either go to Tools and Grasshopper Player, or just type it into the command line. And then I'm going to call the one that's labeled 03 quad panel finished, right? And now it's saying all of those different prompts that we were just talking about. So set the height of the opening, we can set it to 6, right? Set the rotation value, we can give it to 0.3. Set the height of the opening, and you can see each time I give it a new value, it's updating the Grasshopper preview, right? So there's a couple things I want to mention, and I need to go ahead and finish the command. But as soon as this is done, I'll bring up a couple points about Grasshopper. So here, let's just finish this. Let's set the height to 6. The height of the opening is going to be 0.5. The number in X is 10 and 7. And so now if I put this in shaded mode, now you can see we have actual geometry, right? Different groups, because we had placed it in a group. So we have different groups that show our individual panel system. And so if you want, you could then do, some renderings. You could, if you didn't like the set of parameters, right, you could select all and hit delete and then run the Grasshopper Player command, or you could save these to different layers, right? You could be putting these on different layers. And so by this way, you can actually begin to give someone who is very familiar with Rhino, but maybe not so familiar with Grasshopper, a way to interact with a Grasshopper script, right? So I wanted to bring up a couple points. Let me open up that definition and put this back in shaded mode. One thing to note is that whatever is shown in this Grasshopper preview, meaning if I didn't want to see this over here, I could turn this off, right? And I could turn the points off, and I could turn the ellipse off. And now, so whatever is showing it as being visible in your Grasshopper definition is what will be shown when you call the Grasshopper Player, right? Remember, the Grasshopper Player is essentially still using Grasshopper. It's just running it in the background. It's not showing the UI. But whatever has its preview visible in your graph is what will be shown to the user, right? And so that's important to note, is like basically you want to make sure whatever you set in your preview state to be what will be presented to the user. The other thing is to note that the parameter order is kind of important. Well, it could be important if that's what you want it to be. Meaning, let's say you wanted size, let's say you wanted the tilt value to show to the user before the size parameter, right? Whatever's presented to the user, you can set the order based on the Y value of those components on the graph, right? So if you wanted tilt to be presented to the user before size, you would move that value up higher than that. And that would then allow, so it uses the Y axis and the X axis essentially for determining which parameter should be shown first and second and third, if that makes sense. So that's another thing to kind of note if you really want to dial this thing in. Okay, so the Grasshopper Player should be fairly easy, fairly straightforward. You know, if you've used Grasshopper with any sort of regularity, it should be easy to create a Grasshopper definition that can be used with the Grasshopper Player by simply using these context get components, right? And again, there's a number of different data types that you can use, right? If you want to be passing in geometry or points or lines, you can do that. You can also limit what type of geometry you want to be using, right? So if you only want surfaces to be passed in, you can do that. Let's see, it seems like some people are missing, are not able to get it. So Jonathan, you're having issues loading the finished version in the Grasshopper Player?
I was able to load the finished version, but when I run through the process on the player, it's just not baking at the end.
It should be baking to whatever layer you're on. Can you double check to make sure you've got the component in that file? If you open Grasshopper, is it there?
Yeah, the component's there.
And you should see 70 values, right? If you don't change anything.
Correct.
Okay. Let's see. And what version do you have? If you go to here, do you have a current release?
So I don't have the latest one, so I think that's it, because I also don't have all the get options.
I see. Yeah, that's probably, so this was saved with this version, and so it's probably not loading correctly because it's trying to use your version, which may not have all of the different parameters.
Okay.
So I would probably recommend making sure you go and update to 723 or somewhat later release. You could try and replace, you know, I think we haven't used anything that was too out of date. Do you know what version you're using?
Yeah, I was let me try to use my baked geometry here rather than the one.
Yeah, if you delete this one and just replace it with the one you have, and maybe you might have to do the same with these, I'm not sure. Then you should be able to hopefully get some output. But yeah, I would recommend trying to get the latest versions.
Perfect. Thank you.
Yeah, sure, no problem. Okay, going back. Okay, so let's look at a little bit more advanced example. And so I'm going to open up the next one, which is this number 5, which says the Twisted Tower GH player finished. Now this one is obviously a little bit more, you know, not smooth, not well defined. I didn't really spend a whole lot of time cleaning this file up. Unfortunately, I really dislike creating Grasshopper definitions like this, but I was in a bit of a hurry. I tend to try to make things a lot cleaner. But what's interesting here is that we can actually begin to create our own user interface for users using the Grasshopper Player. So what I have here is I can take this thing in the Rhino viewport and use it as a slider, right? So here I'm controlling the number of floors, and you can see it's outputting, telling me what the number of floors are over here. As well as I can create a radial slider, right? If you wanted to create some sort of radial slider, you can do that using this method. And there's really, once I show you how to do this, there's really any number of different interfaces that you can create. And there's a number of pretty interesting experiments that people have done. If you Google, it's probably under GH Player on the Discourse forum, there's a number of people who have shown different examples of what they've done using this method. And really what we're doing is using Kangaroo. I'm going to open now just to show you how this works. Example number 4, which is the simple slider. And so the simple slider, if I turn off the grid because it's sort of showing up on top, is in this case, we're using Kangaroo to try to take a point on a line and constrain it to that line, right? So Kangaroo now ships with Rhino. Kangaroo is if you've never heard of Kangaroo, it is a physics engine of sorts, physics engine for Grasshopper, developed by a really smart individual named Daniel Piker. And it's got all of these different goals that it tries to achieve using its physics engine. And you can create any number of really complicated or interesting examples. And if you Google Kangaroo examples, I'm sure you'll find a ton of really compelling examples. But one of them is this one, if I can even remember it. Yeah, it says on curve. And if we look at the description of it, it just says keep a point on a given curve, right? So that goal is right here. We're defining a point on a curve, and it's telling Kangaroo when we pass it into the goal objects that what we want is for Kangaroo to try to keep that point on that curve. And you can essentially increase the strength value, which tells the Kangaroo solver how much it should prioritize this over other competing goals, right? There's also this component, which is kind of vital in this particular scenario, which is the grab component, which essentially tells Kangaroo that I want to use mouse inputs to be able to grab particles in my scene, right? Kangaroo's using particles as a way to determine where things should go. And this particular component lets me tell the Kangaroo solver that I want some of these values to be able to move around or have mouse input, mouse interaction. So going back to the curve, the on curve goal, here you can see what I've done is all I'm doing is creating a line, right? There's my green line. I'm using the line start, direction, and length. So the length here is controlling how long my slider is, right? So it's 50 units long. And I'm then finding a midpoint. I'm using the curve point on curve component, but this you could use whatever you want in order to find this point on the curve. And once you have a point and a curve, you can pass those into your on curve component, so or your goal. And we pass that in to our Kangaroo solver. And then what is returned on the output is the point that, so what's being passed out here is the point that it has tried to confine to the curve. So if I actually turn this one on, this is the point that I created, which is at the midpoint, right? But now I've used Kangaroo and I've moved that point somewhere farther down the line. And the point that is being passed out is right here. So if I actually select this, you can see it turns green. And that's the point that that Kangaroo has found that is on the curve. And what I need to do is then pull this curve back, or pull this point back to the curve, right? So I'm using this curve closest point, which is saying find the closest point on the curve, which gives me an output value between 0 and 1, right? So it's taking the length of this curve and normalizing it between 0 and 1, where 0 is the start of the curve and 1 is the end of the curve. So this t value that's being passed out here is a representation of whatever my slider is. And now, since I know the target or the t value is always going to be between 0 and 1, I can use a remap numbers component to remap this domain from 0 to 1 to some other value I want my slider to go to, right? So this could go from 0 to 50, it could go to 0 to 1, it could go from negative 100 to positive 100. You know, if you want to change the domain of your slider, that's where you would do that here. And the output then is your value, right? That slider value that, let me turn this back off, is the slider value that you want to use in your definition, right? So this whole thing is basically a version of a linear slider, right? And you can do the same thing on a circle, which is what I'm doing for the radial one, or you can really, like I said, if you look at the examples that are provided or that are out there, there's some really interesting experiments that people have done. I should mention one other thing. If you're going to be using this with the Grasshopper Player, you want to add an additional Boolean input. The reason is the Grasshopper Player, remember, tries to run until all of the input values are satisfied. And then once the input values are satisfied, it solves the definition and bakes whatever's out there, right? So we need a way to tell the Grasshopper Player to wait until we're ready to bake it, right? And so what I have is a Boolean here that's, if I look at the prompt, it says in solution, right? Or bake you could say bake geometry, whatever you want. But essentially this is saying, are you ready to move forward? It doesn't do anything. It's not connected anywhere. You see, I'm not using this to do anything. You could, but in this case, I'm not using it for anything. This is just a way to tell the Grasshopper Player when I call this function to wait until someone actually types something in the command line to finish, right? So if I go back now to that tower example, you can see that I've got my two sliders, they're doing things, but here is that Boolean, get Boolean input. That again is what will be used when I call this function. So let me close, I'll just close Grasshopper so it's not showing anymore. So I will say Grasshopper Player, and now I'm gonna load in example number 5. And you can see now I've got a preview, and it's also showing me exactly what was previewing in Grasshopper, right? So you don't have to just rely on red geometry, the transparent red geometry that Grasshopper is the default color. You can, show whatever you want to show in your display pipeline. But now I can be interacting with this the same way I would with Grasshopper, right? Well, the same way I did with Grasshopper, meaning that I can interact with these sliders, I can change, and you'll notice that I still have I did have one input value, get integer, which is saying how many sides do you want for this tower? So if I change this to 4, now I've got a 4-sided tower, right? I can still control the twist of the tower. You could change the taper if you wanted, or have whatever you wanted. And now you can see here I've hit that in solution. So when I'm ready, I can, and you also see I set a prompt that said yes or no, or options, let's say preset options that are saying yes and no. And so if I set yes, now it bakes that geometry into my scene and I've got an actual tower, right? Because those are the values that are being passed out of the context bake. So that's another way to begin to take the Grasshopper Player into a little further development, a little bit more advanced way to be able to interact with a Grasshopper definition. Are there any questions?
That's super cool, Andy. Thanks for showing that. I had a question about animations. I mean, can you use the Grasshopper Player in combination with, let's say, Kangaroo or something else to sort of, create animations in the Rhino viewport? I mean, since it could solve, I guess that's what the Kangaroo definition is doing, kind of solving the Grasshopper scripts over and over again. Can you do the same for actually like animating stuff?
Well, Kangaroo is solving, but it doesn't show you all of the, Kangaroo's not showing you iteration by iteration, right? At least I don't think. It's not letting you essentially, which you probably don't want, because this is trying to run as fast as possible until it reaches its minimum convergence level. But yeah, I think you probably could set something up to capture or run through iterations, or set something up to run through. But honestly, you're probably just better off doing the animate command there. it's something we've been talking about. Are there ways to create like an animate component? I know there are plugins, third-party plugins, which let you set like an animate frame. So you can pass in like, what is it you want to animate and what frame number and where's the file path, and it sort of figures everything out. And you essentially can create a whole batch set of animation frames. And so there's probably ways. So anything that you can do in Grasshopper will show up in the Rhino viewport, right? So if you're using a third-party plugin and calling Grasshopper behind the scenes, that should work. I mean, it's loading and doing everything the same way. So if you set it up in the correct manner, then it should work straight away, if that makes sense, because it's really loading Grasshopper. You're just not seeing the graph, right? Now, if you distribute that to someone and you're using a third-party plugin, they will also need to have that third-party plugin installed, or it will not work. I believe, I don't have an example of this, that if you've opened a Grasshopper file before that has a plugin that you don't have loaded, you're often presented with a dialog that says, missing third-party plugin, and it'll try to find it on the package manager if it's there. If it's not there, it'll just say, I can't find it. You should still be presented with that dialog, I think, when you try to launch a file with the Grasshopper Player and it has a plugin that is not found on that user's machine. But we don't really want to handle installing third-party plugins automatically for people. That's not something I think we feel very comfortable. And so you would still need to make sure that whoever is using this particular file has all of the necessary plugins.
Makes sense. Thanks.
Yeah. Okay.
I have a question.
Okay.
I set up a definition once that uses this exact technique because I saw one of your tutorials. It was really cool. The thing though is that it doesn't run in parallel. So for instance, you can't now run, or at least when I did it, I couldn't run another command and keep this interface active.
Yep.
Is there any way that is that just how it
That's how it works. So basically, the Grasshopper Player, the reason it's used is to call a Grasshopper definition through the command line. And you can only run one command at a time, right? If you have something open, see, this is running options. And so I can't run another command while this command is being run. I have to cancel this before I can actually run another option, run another command. And so unfortunately, you wouldn't be able to run another Rhino command concurrently with the Grasshopper Player, because that's just not how they're set up, right? They're set up to run one command at a time, and essentially the Grasshopper Player is a command.
Is there a way to do it through Rhino Compute?
Yes. Yeah, because just like we're running Grasshopper right here, and I can still interact with this, so you can see my Grasshopper definition, but I can still call the circle command, right? So Grasshopper does not end up locking up the command line, and so yes, you can. And so when we use hops and compute, we will be essentially using Grasshopper as a way to call the functions versus the command line, which is what the Grasshopper Player uses.
Got it.
Does that make sense?
Yeah, that makes sense. Thank you.
Yep. Any other questions?
How about the remote panel in Grasshopper? Can this be combined with that in somehow? I mean, related to the last question about having something sort of running in the background and you want to fiddle about with the parameters.
That is a good question. It is not one I have tried to. Yeah, so we do have a little bug actually. Well, so that brings up an interesting point. There was see if I can explain this. So when the remote control panel is on, for some reason, sorry, let me take this back. When you call the Grasshopper Player command, it tries to keep that file open, even though it's finished. So you saw, for example, there was that quad panel that was showing up in the viewport, even though it had. So if I turn this back on, see there, you can see it's open and it's right there. It's showing, even though I ran that a while ago, right? The reason is that it kept that file open because there's certain plugins that actually want, like human, for example, if we were to shut down the file, it would shut down the instance that human uses and things like that. And so we decided to keep it open. But obviously, you want to be able to have the option of whether to close that or not. And so, for example, you can go to document properties and oh, there you go. The reason is that in Rhino 8, I guess we didn't cherry pick it back to Rhino 7. So in Rhino 8, there's an option to close the Grasshopper file if it's being called by the Grasshopper player. So I'll launch really quickly Grasshopper 8 or Rhino and Grasshopper in Rhino 8. Which if you have a valid license in Rhino 7, you can download and try out Rhino 8 for free. You just Google Rhino 8 download, and here it's launched. And so here is Rhino and Grasshopper for 8, Rhino 8, and you'll see it says Rhino whip. But if I go and say File, New Document, and then go to the document properties, there is this checkbox that says keep open or not after the command completes. And so by default, that is unchecked. And so now in Rhino 8, when you run the Grasshopper Player command, it would shut down that file after you've run it so that you don't get what I just showed over here, which is these sort of artifacts showing up in the viewport, right? Because in 7, it doesn't have that flag. And so it has by default kept that file open. Ooh. It has kept that file open in the background, and that's why you're seeing it. Now, for some reason, it only does that when the RCP panel is open. If you close it, and then I think, yeah, redraw, it won't show up. So there is a bug in our display pipeline somewhere that when the RCP panel is open, that it does show previously open or run Grasshopper Player files. Like I said, if you have that, if you use Rhino 8, you have the ability to set that values to close it so that it won't happen, right? So you can save that with the document or not and click OK. And then when you run it in Rhino 8, it won't keep that open. Does that make sense? But I think your question was broader perspective. Could you actually publish slider values? I don't know, to be honest. It's not something I use a whole lot. And so I don't want to say one way or the other. I think it's worth experimenting. And if you find a bug with it, then let us know. If it works, great. If it doesn't and you want it to work, then let us know. And we'll see what we can do. So we rely heavily on user feedback. And if there's features that you think you want or need that it isn't working the way you want it to, then you can just let us know and we will do our best to try to work that in.
Awesome, thanks.
Any other questions? All right, so why don't we take, it's 3:13, why don't we take, a 5 or 6 minute break. Let's come back. It's 3:13 my time. Why don't we come back at 3:20 and we will start back and look at Hops and Rhino Compute. If you have any questions, you can submit them on the Slack channel and I can try to get them during the break. I'm going to grab a quick drink of water and then I will jump back online in just a few minutes. Hey guys. Is everyone back and ready to get going again?
Yep.
Okay, cool. All right, so everybody can see my screen and hear me okay?
Yep.
All right, perfect. All right, so the second half of this workshop, and again, if you have any questions about the Grasshopper Player, feel free to just stop and ask me, but the second half of this workshop is going to be all about Rhino Compute and hops. And I'm going to really try my best to explain what those different pieces are, because they're not exactly the same thing. A lot of times I think people get confused, and it's probably partly our fault in how we have explained it to users, what Rhino Compute is and what hops is, because they are not the exact same thing. And so I'm going to really try to do my best to explain it in as clear as terms as possible. And really, hopefully, if you get anything out of this workshop today, it would be that you understand the fundamental concepts between what is Rhino Compute and what is hops. So really, hops is a way to take something like this big, large spaghetti code and package it up in a way that can be much more concise into what we're calling a hops function, right? So it lets you take an entire definition or parts of a definition and make it into a reusable function that can be called using Rhino Compute. If we look, sorry, let me go back. If we look at it more specifically, it lets us simplify a much larger complex definition. So you could load the entire function like I just showed, where you load the entire graph and it gets called in a single hops function or component. Or you can break your definitions down into smaller functions, which is really where I see the benefit of, someone asked, can I put hops in hops? Oh, are you talking about recursion? Yes, you can put recursive functions. If Callum, I think the question was, can you put hops? Okay, yes, the answer is yes. But what we're going to show, so what this allows you to do is take parts of your function and try to create reusable blocks, if you will, and this allows you to load them into other definitions later down the road. So if you have something that you use over and over again to create panels or create a grid or something like that, you can create a hops definition that can be then loaded using hops, and you can use it over and over again or share it with colleagues. In addition, it lets you, like I said, simplify these larger complex definitions into easier to read definitions like this. So if we look, we're essentially using the same ideas that we just talked about with the Grasshopper Player to create a function that can be called with hops. So if you remember, we were just talking about when we create a function, we have some inputs and an output, and we're using those context get components that are found under the params util group, right? So we have our context getters and our context print and context bake component. Those are the same components that we use to create a hops compatible function, a function that can be called with hops. Inside, this can be any number of components that does something to return the result, right? And when we load hops, or when we create a hops component, we have to pass in a path to a Grasshopper file. Now, this could be a location on your computer. It could be a URL to a server, or it could be a remote endpoint somewhere. But we have to give it a path. And when it does, it will then use that to solve and return a result. But let's look a little bit closer at what I mean by return the result, because that sounds all good and well. But let's say we had, our hops, let's say we had a computer that was running hops. This is your computer. And it's got a Grasshopper definition, and we're using hops. And somewhere over here on the right-hand side, we've got Rhino Compute, which is a little application that is running the Rhino Compute server, okay? So this is just an application, and its job is to sit there and listen for incoming HTTP requests. All that is just a way of saying it's listening for a web request. So every time you browse on a website, any website that you go on the internet is sending web requests to a server somewhere in the background. It might be a remote server or it might be somewhere close, but it's sending a request to a server to provide some information. It could be an image, it could be some text, it could be this, that, and the other, but essentially every website that you use nowadays is communicating in some form or some fashion with a server in the back end. And a server is just is just a name for some sort of application that is listening and serving up information to a client. In this case, the client is our hops, our Grasshopper definition. But the client really could be anything that can send and receive HTTP requests. So you could create a website that talks to Rhino Compute. You could create an iPhone app that talks with Rhino Compute. Anything that can communicate over the web using HTTP requests can communicate with Rhino Compute. So let's look at this. So we have this, your laptop, let's say, or your computer running hops, and this is the definition we want to solve, right? It's that simple example where we're adding, in this case, we're adding two numbers, right, and returning the result. So we set the path on hops, and it says, take this file and send a request over to Rhino Compute, right? So Rhino Compute is, like I said, this application, and it could be running also on your computer. It's just another application that is sitting there listening for these requests. So this could be on your computer, or it could be on a computer halfway around the world. But it's just listening for an incoming HTTP request. And when it receives it, it takes in the data and then processes it, right? It does something with it. So once it's done, it then sends a response back to the client, right? So again, the server's job is to do something and pass the results back, right? And that's essentially what Rhino Compute is, right? It is a web server that provides an API for geometry calculations using Rhino's geometry library. So really, if you think about it, all it is a server that is listening for these requests, and it can use all of Rhino's geometry kernel to perform some calculation. So thinking about that in a different way, it's kind of like a headless version of Rhino. Headless meaning that there's no user interface. It's just a little console application, but it can do everything that Rhino can do, right? So anything that Rhino can do, lofting or creating patches or sub-Ds and things like that, anything that Rhino can do, Rhino Compute can do. The only difference is there's no user interface. So you have to communicate and do things passing these HTTP requests. Does that make sense with everybody? To go a little further, once you've installed hops, you will then be able to go into the Grasshopper settings panel. And if you click down here under the solver, up on the upper right-hand side is where you will see all of the hops preferences, all of your hops preferences. And there's one thing I'd like to note in particular is this one checkbox, because by default, this is checked on, which is to say, I want to hide the Rhino Compute console window. This is because some people, when they install hops, they don't want to see an extra little application load in the taskbar. But I like to unhide it, so that when you launch Grasshopper, what you will see is this little console application that shows up in the taskbar. This is Rhino Compute. So this is the thing I was telling you about, that every time you launch Grasshopper, Rhino Compute, this web server, launches in the background and is just listening for incoming HTTP requests, right? And it's useful to uncheck that so that you can see it. And if something goes wrong, all of the debugging and error information is printed to the console window. There was a question about what is the relationship between Rhino Compute and Rhino.inside. So Rhino Inside is essentially the library that gets loaded that allows Rhino to be run in .NET or Rhino to run as a console application, but it's not. So Rhino Compute is the server part. It's the like listening for HTTP requests and passing it on and performing. And then once it passes it on to, all right, actually, if you really want to know the nuts and bolts of it. So Rhino inside is the core library that is running the Rhino kernel, right? There are two, well, this is probably getting a little bit. Let me answer that question. Can you ask me that question in a bit? I don't want to overload you too much too quickly. I'd like to be able to explain a few things before we get into the advanced details about how Rhino Compute works. So if you'll just give me a couple more minutes. But really what I'd like everyone to understand is that hops and compute are two completely different things, right? I mean, they work together, but compute, Rhino Compute, if I say compute or Rhino Compute, they're the same thing. Compute is just a server that is running Rhino in the background, right? You can't really interact with it. It is just this little console window, but it is running Rhino in the background. And it just listens for incoming requests. And hops, what hops is a client, meaning if you Google client server relationship, the client is the thing that talks with the server. And a client can be any number of things. So again, hops just happens to be one type of client that can communicate with Rhino Compute. But if you wanted to, you could create a website, like a little web configurator, if you will, to talk with Rhino Compute. So you would essentially have a little web configurator with some sliders and things like that, and it would send the HTTP request to Rhino Compute to give you the geometry, and then when you get the geometry, you visualize it on your website. Or same thing, you could create another plugin, or you could create an iPhone app, or really anything you want, and run Rhino Compute in the background to perform the geometric calculations. So let's launch Rhino. But really, that's the key today that I hope each of you walks away with, is this understanding of exactly how hops and compute work together, but are not the same thing, if that makes sense. So again, hopefully you have all installed hops already. And when you do now, I'm going to launch Grasshopper again. And you can see that as soon as I did that, there is now a little application. Hopefully you can see. Can you guys see my taskbar? Are you seeing my full screen? Yeah or no?
Yep.
No taskbar, I think. Yeah, maybe yes. Okay, now is it? Yep.
Oh, okay, good.
We can see.
All right, so there's another application that has a little different colored icon. And if I click on that, that is our Rhino Compute. And it's doing this because we have installed hops. If you had uninstalled hops, you will not see this anymore. But the reason why you see this is because if I go to File, Preferences, I have and then go to Solver, I have unchecked this hide the Rhino Compute console window. If this were checked and I restarted Rhino and Grasshopper, that would not show up. And that's actually the default state. But what I would like each of you to do is uncheck it. And then if this was already pre-checked, you're gonna have to restart Rhino and Grasshopper. But when you do, the next time you do it, you should see this application show up. And what this is doing is, like I said, this is the Rhino Compute instance that is running locally. And when we use hops, by default, it will start to communicate with this particular server. You can also see right here, it says now listening, when you launch it, it says now listening on localhost 6500. This is the URL that this particular server is listening on. So localhost is just telling hops, or the address of this particular server that is being run is local host, which just means it's on local to your computer, right? So local host just means it's on my computer. But if you had a server set up somewhere else, this would not say local host. It would be a different IP address, right? It might be something like 192.255.0.82. And then you see a colon, and then you have a port number, right? So this particular server is listening on localhost 6500. When I go to, and I don't want you to click into this text box here, don't click into it. But when you go, if this is blank, if this, you can see it says Hops Compute Server URLs. If this is blank, then it will automatically try to launch an instance of compute for you and start to communicate with this URL, right? If you had a server running remotely, and remember I said I'm not really going to go through the steps of showing that, but just to show, I'll copy the link over there. So if you go to, let me just real quickly show this. We have, if you look at Rhino's developer documents, there is a section on compute, and there is a couple of sections on production deployment. And so this teaches you how to set up a virtual machine if you're using Azure or on AWS. But then there's one called deployment to production deployment to production servers. And I'll just copy this. And this essentially just lets you run two scripts there. You can just essentially copy this, and it goes through the whole process, but you just copy this, and this goes through and sets up everything on your virtual machine. And then you do step two, you just copy and paste this and run it. And this sets everything up on your virtual machine to create a server that you can talk to. And when you do that, I'll copy this into the chat so that you have access to it. But when you do that, that would be then the URL that you would paste in over here, right? So I don't want to do that. I just want to be talking to this server, right? Because this is running on my machine, and I don't have a remote server set up somewhere that I can talk to. But again, I'm just showing you that's the location where you would put that information in. And that's what tells Hops, like, do I want to try to send my request to this address, or do I want to send it to some other address? And that's where you start to put that information in. Okay, does that make sense so far?
Yep.
Okay, great. So let's look at a really simple example. Let's make a really simple definition that we can call using Hops. So what we're going to do is go to the params. Let me just maximize this because we're not really going to be looking at any geometry. We're going to go to the params util group, and we're going to say get string. In this case, we're going to create a sort of hello world example. And we're going to be passing in our name. It could be your name, your friend's name. But so I'm going to right click on this. And remember, with Hops, the name of the component is important, right? So this is what will end up becoming the parameter name. If I go back to my PowerPoint slide over here, you can see that I've defined num1 and num2 in these as the name of each of these parameter inputs. And then when I solve it, it names each of those parameters as inputs and uses the name as that input. Does that make sense? So the name is important when you're using it in Hops. So you can say this as username, right? Whatever you want this parameter to be called when Hops loads the definition. So what we're going to do is use the concatenate, which is a way to add strings together, text together. So we're going to add a panel here, and we're going to say hello. And then we're going to use our name input here, our username input to join. It says hello. And notice I also added a space after the word hello. And then if I want just to be able to see a default value, I'll say Andy. And then we might want to add one last one. So if you're new to Grasshopper, some components have what's called a zoomable user interface. And that happens to be one of these. So when you zoom in close enough on some components, you have the ability to add multiple inputs. So you can see I can remove or add using the plus or minus button. So if I hit the plus button, I can add a new input parameter. And this one is just one that I want to say space and then exclamation point, right? And so I'm going to use that into the A input or the last input. And then to see what is coming out, I just want to look here, and obviously I don't want to put space. Can't really type. And so this is the text that we want to return. So what we're essentially showing is I am creating a definition that is going to have one input parameter called username, and then it's going to be solved on hops, and then it's going to return a result that looks like this. So I need to actually have an output, right? And so we use either the context bake or the context print to determine the output value of our hops component. In this case, you can leave it as text, you can leave it as message, you can say whatever it is you want the name of the output parameter. But please note, I do want to highlight this, that for inputs and outputs, the names have to be unique. You can't have two outputs that are both named message. If you do, you will get an error message, and it'll say two components with the same name or two outputs with the same name were detected. So each of your inputs and outputs, the names have to be unique. I'm going to leave everything else by default here, like the at least and at most, and the prompt is not really that important here. So let's go ahead and save this. I'll save this to my desktop, and we'll call this, I already have a hello world, so I'll say hello world 2. And then I'm going to open a new Grasshopper document, right? So I've now created my function, and now I'm going to use hops to communicate with this server. So let me see if I can move some stuff around so that you can actually see the server when I hit it. Actually, oh, sorry. Okay. Too many windows. Okay, so now that I've got my Grasshopper definition, I'm going to go down and look at the hops component. So under the params util tab, we have the hops component. And you can see that by default, the hops component is orange because it says no URL or path defined for the definition. So I can double click on it, or I can right click on it and say path, right? So that's the path. And you can see it says URL or path, and there's a little folder. Now, since I saved this to my local computer, I'm going to click on this and go and locate Hello World 2 that I just created, right, on my desktop. And I will click OK. And as soon as I do, I had this issue the other day too. I believe what's happening is that I think what's
sometimes the console gets hung up if you like hit enter or something in the console.
Oh, there you go. Thanks for that. You're
nice.
Right. Yeah, when I selected all those things, it was waiting for me to hit enter. So what you're seeing here is the messages that are being printed to the screen based on what we sent. Now, I'd like to actually, well, let's finish this, and then I'll talk a little bit more about what you're seeing. So now it knew to take the definition, and it knew that we had an input value called username and an output value called message. And also it's already done a solve because it had a default value, right, for Andy. But if I go and put, a different message, let's say Sarah, right, and click OK. Now you should be able to see that I have a result that says hello Sarah, or we could try David, right? And every time we make a change, it's sending a request. You should be able to see your server updating with a new message or two, and we should get a new result. Now, let's look a little bit closer about what we see here. So the very first message that we received was this one that says post and then IO. Now, there are different types of HTTP requests that you can make. The common ones you'll see are get and post and sometimes delete and things like that. But in this case, this is telling me that there was an HTTP post request sent to the endpoint called IO. Okay. All that means is that the server has certain endpoints. An endpoint is just like think of it like a function that it's running that says when you give it this URL. So it would be getting like a URL like this. So remember, we had HTTP localhost 6500 and then IO, right? Something like that. So it knew that to go to this address, to this port, and then call this function called IO. And the IO function, its job is to sit there and take in a definition and look for all the inputs, the context get components, and the context bake or the context print, and determine which ones are inputs and which one are outputs, and then send the result back, send a response back that tells hops how to build the component. Because remember, by default, it looks like this. It doesn't have any inputs or any outputs, right? So the very first request that is made is going to determine, tell hops how many inputs and how many outputs does it need to create. Then once we pass some values into those inputs, once it has enough information to solve itself, it then sends another request. In this case, now it's saying, it's not going to the IO endpoint, it's going to the Grasshopper endpoint, right? You can see, and you know that because you can look at this console window and you can see it says the very next one in our definition was a post that says /Grasshopper. And you'll also see these messages that say responded 200 or something else if it didn't work. If you are new to web requests and things like that, I would recommend going to Google HTTP error codes. And you can just look up, there's a number of them here, but essentially there are all these different codes that provide a little bit more information about how the server responded. So 200 actually means great, it worked, right? So if you see a 200, it means the request succeeded and it was able to get, talk to the server just fine. But you might see other ones, like you've probably seen a 404 message or a 401 message, like a 400 or 404 with a website. That's telling you that the server couldn't find the page that you requested. Or if you got a 403, it means you didn't have the rights to access it, or 401. So these codes that you see here are sometimes helpful to determine how is hops, which is my client, is it able to get a request through to the server, which is this guy, right? So this is how we start to read this information. You can see it took a little while. That first one took a little while because I was stuck in that hung up mode. But in this case, the actual solve only took 82 milliseconds. So the Grasshopper one is when it's got all of the input values. It's then going to pass those values to the file that we sent it during the IO part and perform the calculation and return the result. Now let's look even closer to what those requests and responses look like. If you right-click on a hops component, you should be able to see that there is an export. And down here, you can see that there is REST API, and there's one that says, export the last IO request and last IO response and the last solve request and response. So this is a way to really dig down even further to understand what is the request look like that Hops sent, and what is the response that it got. So let's actually save these. I'm going to save them on my desktop, and it saves the request as what's called a JSON file. So I'll just call this IO request, and then I'll right click and export the IO response. And then I will do the same for the solve. And the same for the response. And then we're going to use we're going to open up Visual Studio Code. Hopefully each of you have downloaded and installed Visual Studio Code, which just happens to be, I think, one of the better text editors out there. So I'm going to go to my desktop and open up those 4 files so that we can look at exactly what was happening. So the very first one is the IO request. So remember, that's when Hops loaded as soon as we set the file path that we wanted to use, it's going to take that file and send the IO request to our server. So if I right click, I can say format document, and it's going to just make it look a little bit cleaner in Visual Studio Code. But you can see that this is the URL that it tried to send it to, right? Remember, it tried to send it to localhost, and then the port number was 6500. And then you can see that the endpoint that it tried to hit was the IO endpoint, right? So we just talked about that. So this is the function in the server that knows that I need to take in a file and look for the inputs and outputs and return a result. You can see the method was a post. It gets some information about the document. And then here you can see the algo is the algorithm. And this is a really, really, really long string of numbers and alphanumeric values, which are essentially is a base 64 encoded string of our Grasshopper definition, right? So what that means is when Hops when we set the path to our definition, it took our definition and essentially converted it into this really long string, right? So that it could send it over with an HTTP request. So it's essentially converting that file into a really big long string, which is just text. And then it sends it over to the server. The server then gets that value. And again, I'm going to right click and say format document. It gets that this JSON request message, and it takes it into the function called IO, and then it processes it. It does some stuff with it, and then it returns a response. In this case, one of the things that we want to look at is the cache key. This cache key is now a pointer on the server. It's just an ID, right? It's just a unique ID that's saying, next time you send a file, next time that Hops component sends me some information, you don't have to send me the entire file again. You don't have to send this giant long string, because that takes up a lot of time, right? It's a really long string. It might take some time. Instead, you can just send me this pointer, and when I do, it's going to go load that file in the cache and use that, right? So this is just like a little shortcut, which is saying use this value to go find the file that you saved when you received it. And then you can see it looked through the file and it found that we have an input called username and an output called message. And then it even goes further and says, like, what are all the values of our input? So it knows that this one has a default value called Andy. The name is username. The type of parameter is a text parameter. And same thing with output. So you can now see a little bit more about, this is how Hops received the information coming back and knew to make a input that was expecting a string and an output that's called message that's going to return a string, right? So then the next step was we passed a name into the input, right? And it took that name and sent another request. And another request this time was going to our local host, but this time hitting the Grasshopper endpoint. And you can see it's using the pointer instead of sending that big long algorithm, right? So the algo, we don't have to send that algorithm now. In this case, we can just send the pointer, and it's when we do that, it's telling Grasshopper, hey, go look up this file, and that's what we want to use. And the values are saying, go and look at this parameter called username and pass it the type of string and pass it the word David, right? And then it does that and sends a response back to us, which is just saying that, okay, I got everything, I'm still using the same pointer, but the result is going to be output of the output called message, and it's going to be this, right? Hello, David. So by looking at this, I think helps explain a little bit more about how Hops and Rhino Compute communicate with one another, right? This lets you understand a little bit that Hops is taking your file, putting it into a base 64 encoded string, sending it over, getting their inputs and outputs back. Then once you give it a value for the input, it sends those values over and gets the result and sends it back. Does that make sense to everybody?
Yeah, I think so.
So there are a couple. There's a couple of questions on the chat that I wanted to highlight. So one thing you'll note is that, remember, we are running compute locally, right? So when I launched Grasshopper, it automatically created a server that is running on my computer, right? So you're not probably going to see a whole lot of, unless you run it and have a definition that is running in parallel or asynchronously, you're not going to see a whole lot of speed. Well, that's not true. So this is running locally and it is free to use, okay? There is no cost, as long as you have a valid Rhino license, you then can, there's no cost at all to use Rhino Compute, okay? So I do want to make that clear. Rhino Compute can be free, especially as long as you have a valid license, your Rhino license. Rhino Compute is free and you can run it as much as you want and send as many requests as you want. If, however, you decide you want to set a server remotely, right? Let's say you have a, it looks like, well, Callum, I will come back to your question. Let me finish this one. Let's say we set up a server using that guide that I just talked about, right? So we run through these steps and we set up a server on a virtual machine. That just means it's going to be a machine that's running somewhere in the cloud, but it's running basically the same server that's running here. Now, the thing about this is you're going to be running it in on Windows Server, not Windows like Pro or whatever you're using. Like I think I'm using Windows Pro, but when you do it on a virtual machine, you end up using Windows Server, and we have a different billing method when you are using Windows Server. And that's something called core hour billing. And there is a lot more information that you can read, especially if you want to look at the core hour billing guide. But essentially, what this means is that it is going to look at the number of cores on your virtual machine, right? So you might have 8, you might have 16, you could have a huge cluster that has tons of cores, or you could have a really low powered one. It's up to you, however you want to configure it. But it looks at the number of cores and the number of hours that those cores have been on and working on Rhino stuff. And it's basically 10 cents per core per hour. And that is just a number that we tried to set up that we thought was fairly reasonable, that would not hopefully be super cost prohibitive, but also at the same time, give us a way to have billing for using something like this. Now, so when you are running it, or when you are running a remote server and trying to use Rhino Compute, there are some additional costs. So you have to go through this guide and set up get a Rhino token and things like that. So there are a little bit of other steps, but what I want to highlight here is a little bit about how, and maybe this diagram, let's open up. A little bit more about how this diagram works, because somebody had I think Nathan had a good question a minute ago, which was, how does Rhino Inside and Rhino Compute kind of work together? And I think it's a little bit easier to think about how Rhino Compute is set up to work. Now, this is getting even more advanced. This is really just talking about the remote setup, but it does give you a better understanding about how the compute server works in general, because essentially we have a application called Rhino Compute.exe, right? So there are two projects that if you, and I should mention that Rhino Compute is open source. So if you have not, if you would like to, let me see if I can open up the file. You can actually pull down the repo, or actually, hopefully you already did, because you pulled down the Git repo for the workshops. But it's open source, and you can look at all the code for how it's structured. But there are two projects that get created when you build Rhino Compute, and one is called Rhino Compute exe. That is the server that is sitting there listening for incoming HTTP requests. Its sole job is just handling the incoming HTTP request. Once it has received one and then authenticated, so there is a layer in there that handles authentication with an API key. So once it knows that it has a valid request, it then goes and tries to launch these child processes, which are called ComputeGeometry.exe. And you can launch as many of these as you want. Now, you only start getting billed when Compute Geometry's children get spun up, get launched, right? So as soon as it gets a valid request, it starts up, you know, any number. You can set this to be 1, or you can set this to be 10, or however many cores you have. You can set up how many children you want it to spin up. But then it'll spin these up and then start to pass those requests on to each of these children. The children are sort of what's running Rhino.inside. It is the one that is loading, is doing all of the actual Rhino calculation, if that makes sense. So this is what is running and performing the calculation. And once it's finished, it then passes the response back up the chain and over to our client, right? The reason we structured it this way is we didn't want you to be billed 24 hours a day. Let's say you have a virtual machine and you were just running ComputeGeometry.exe. You could hit that with an HTTP request and it would perform the calculation. But remember, you get billed as long as Compute Geometry is running on that machine. So we didn't want, if you had your virtual machine running 24 hours a day, for you to get billed but weren't using it 24 hours a day. You know, let's say you had a couple of users that were using it to send some requests, but then after a couple of hours, they were done. What happens is with this structure, Rhino Compute has what's called a timeout. And if that time, if it hasn't, which is default set to an hour, but you can actually customize that. But let's say after an hour, it has not received any more incoming requests, then it will actually close down all of these children. And then you don't get billed anymore. This Rhino Compute exe can stay up and listen for any incoming request, and it will do so. But as soon as it gets a new one, it will then check to see if any of them are up, and if they're not, it will then spin them up and you know, pass on the information. Does that make sense? So this configuration of having Rhino Compute and then a child, or sort of a parent-child setup, it lets us have the ability to close down the part that is what's billing you, and close it down and just have the parent part, which is listening for the request and doing the authentication. So that hopefully provides a little bit more information about how Rhino Inside and Rhino Compute and how they're structured in the code. Does that make sense?
So Andy, so are you saying that like built into the server is like a job queue and a scheduler, and it'll scale any number of
a little bit. It's not I mean, it's just a round robin scheduler, but yes, it's basically launching an application, and then you can see called Rhino Compute. And when it runs, it's then going to spin up compute geometry, right? In this case, it's just running, I think, a single instance of compute geometry. But when you start it up remotely, you can actually pass in a number that tells it how many processes you want to provide. And the reason why that's important is that's where the parallelization comes in. So let's say you send it like 100 requests really quickly, and you had 10 children, it would start to send those requests to those 10 children. And as soon as one comes available, it sends it to the next one, right? And so that allows you to essentially create your parallelization setup in your server. Does that make sense?
Yeah, thank you.
So there are two projects. So there are two executables, but one is essentially running this one in the same process as a child, essentially. So Rhino Compute is the one that's up all the time, and then it's the one that handles distributing the ACTP request to the compute geometry, which is doing all of the actual calculations.
And are there any scaling limits there? And if one of them fails, is it just feeding whichever one finishes first to the output stream?
Yeah, basically. And then if one fails, it tries to relaunch it or tries to relaunch a new one, things like that. So with this also is another layer, which is called IAS, which I didn't really want to get into, but yes, essentially this is all handling incoming requests and making sure these are working properly. If they don't work properly, it tries to spin them back up. And like I said, if they're not being used, then it tries to shut them down so that you're not getting billed. But really, you probably don't want to do it more children than you have cores, right? Because then, I mean, you can only really use a single, remember, each one is essentially like a version of Rhino, and Rhino is sort of single threaded. So in that case, you're kind of doing, you probably only want the number of children as the number of cores, essentially, but you can kind of configure it based on your needs, right? So again, when you set up your virtual machine, if you only have a small user base and you don't want to spend a whole lot of money, maybe you set it up with only like 4 cores or 2 cores. But as you begin to develop your definition and then it becomes kind of slow and you want to increase things, you can configure your virtual machine to have more and then increase your children and so on and so forth. So that's a little more than I wanted to cover, but at the same time, I think it's also important to explain the billing, because that's another question we get a lot in about hops, which is how is billing handled? And like I said, if you're doing all of your requests locally on this server, it's free. It's completely free. And so what a lot of people do is they develop their Grasshopper definitions locally as a way to prototype, right? So they might make some functions that test locally and things like that. And then when they get things working to a fairly stable point, that's when they might deploy a production server. And again, then they just go to the preferences and change this. And now you would be sending your files over to that computer. But at that point, that's when you start getting billed on that other account, right? The core hour billing account. But so as long as you're running it locally, there is no cost for running hops or compute. There was another question, but was that answered or not?
Well, sorry, you answered half of another question. You described kind of how the input gets cached. I'm just wondering if there's any caching of the output that you get without any work, or would you have to set up like a proxy server to cache the output coming back?
That's a great question. There is, but it could be better, is the short answer. So if we right click on this, you can see there's one called cache in memory and cache on server. The cache on server basically tells it to store the value on the server. In this case, it's local, but if you're sending it to a remote machine, it would store the result. And so every time you sent, let's say we actually had a component that had 4 or 5 inputs, right? Every time it received that same configuration of input values, it wouldn't have to resolve the definition because it's already done that. And has stored the result in the cache. And so it can actually very quickly speed up things because it's storing things in the cache. And so you could theoretically create a script that would run through every permutation of all your sliders, right? Let's say we had 3 or 4 sliders, and it's going to run through all your different values and send the request over to hops. And now you've got all of your values stored in the cache. And so now every time you hit it with any kind of value, it's going to be instantaneous, right? Or fairly instantaneous. It'll be very quick because it doesn't have to redo the actual solving. The one downside, I think, with this is that it's storing it in memory, which means it's storing in memory on the server side. And we probably need to do a better job and have a persistent data storage, because I just talked a little bit about how Rhino Compute will shut down these things. And then IIS actually has a timeout limit, which will shut down Rhino Compute. So again, if it hasn't received any incoming requests, it can shut down Rhino Compute. When that gets shut down, all of that memory is lost, right? All of that cache is lost. So probably what we need to do is provide a mechanism to store the cache persistently. And then when you hit it, it will pull from that cache. But that is on our roadmap. It's just not something we have implemented yet. Does that make sense? So that's another real benefit, though, is the caching can really speed up large definitions. Let's say you've got a definition that's performing some sort of simulation, and it takes you 10 seconds or something per iteration, right? Every time you change a slider, it sits and waits 10 seconds. Well, if you were to do this with hops and you actually pre-computed all of the values that you were going to be using, now every time you do it, it's going to be instantaneous. So when you're presenting to a client or something like that, the results would be instantaneous. Or if you were trying to make an animation, right? So that's another thing you could think about, is that it would also pre-compute your animation values. So the local server, how many parallel? The local server isn't really going to help you that much with parallelization because it's really only spinning up a single instance of compute geometry. It's not, and you can see it's on port 6001. It's not really spinning up multiple. When you load this on the remote virtual machine, you would actually see multiple compute children, and the console window would say, you can see it, the compute geometry messages are the ones that have CG next to it, right? So all of the ones that don't have CG are the ones from the messages being printed by this application. And all of the ones with CG prefixed on it are the ones coming from each of the children. And so CG in this console is saying the compute child that is listening on 6001 is telling you that it's loading Grasshopper, it's now loading the plugins, and so on and so forth. So when you load this on a remote machine, it'll actually say CG 6001, CG 6002, CG 6003. And then the Rhino Compute server is the one, or the main layer, the parent layer is the one that handles sending them to those different port addresses. And so you don't really get a whole lot of benefit when you're doing parallelization locally, but the real benefit would be when you set it up to run like on a remote machine. Now you could configure this and run it manually and not have Grasshopper set it up. And you could actually set, let's see, does this actually update? Let me see what happens when. Hang on. I just want to test something. So here you can see it launching. And sometimes this takes a little while. Yeah, okay. So you can actually, I take that back. I was wrong. So I gave you some wrong information there. So I have a value here set to 1, which is why it loaded very quickly. So you can see it's taking a lot longer to load, but it only spun up 1 child. And in that case, it's not really going to give you a whole lot of benefit of parallelization. But you can change this value here, right, for your child process count. And you can say, you can increase that. And now when I restarted it, you can see it took longer because it had to create essentially 3 different instances of Rhino, right? But now you can actually see that we have compute geometry 6001, which loaded. We have compute geometry 6002, and then we have 6003, right? And so now when you send it files, it will try to hit those different ones, which brings me back to this at least and at most, because I think that's also a thing that confuses people sometimes. Let's say we had a get number parameter, and we have this set to at least is set to 1 and at most is set to 1, right? That tells hops that when I create the parameter, remember it's going to create a parameter here called whatever, get number, that it's expecting a single value to come in, right? If it's set to at most 1. So it's saying, okay, when I get a single value, send the request over to hops and perform the request, right? Does that make sense to everybody? The next step is if I set it to at most either unset it, like I can just hit delete and say commit, or I can set the at most to 10. Anything more than 1 will then tell the parameter, remember, it'll now set this as list access. And the list access is now saying, okay, I'm expecting, a list of values. So in this case, I can use like the range, and it's going to take all 10 values here and then send 1 request with those 10 values, right? So it's going to take this entire list and send the request over to the server with all 10 of those values. Now, what happens if I set this back to 1 and this is set and I feed it a list? Anybody know? Anybody got a theory?
I guess it would run the components several times, like solve.
That's right, exactly. So if this is set to 1, if at most is set to 1, but I give it a list, it's now going to treat each one of these as an item, right? So it's sending them, it's going to send 10 requests, right, over to the server. Does that make sense to everybody? Because that's important to understand, is you have to kind of understand what you're expecting in order to also understand like how many requests are coming in and out. So if I wanted a single value to come out, like if I expected a single list to be passed in and a single value to come out, you would set that to list access by setting this unset or something more than 1. If you set it to 1, then it's going to treat each one of these as an individual request. And that's when the parallelization part comes in handy. Because let's say you're sending it 100 values or 1,000 values, right? It's going to start taking each one, but you do it accidentally, right? Because this is set to item and you accidentally give it a list. Now you're sending 1,000 requests over to hops, and it's got to individually start passing those out. But if you have multiple children, you can do that, right? Because you're sending each of those requests, and hopefully it goes pretty fast. But that's where it can get tricky, is understanding when you would use 1 and when you would use a list. Now, before, until fairly recently, hops could only work on items or lists. It didn't really work well on trees, but that has now been fixed. So if you expect a tree, you can set that to true. And now when you send it, it's going to take in the entire data structure. If it's a list, that's fine, but you can send it an entire data structure into it, and it will only make a single request over to hops, but pass the entire tree as the value. Does that make sense?
Yes,
okay,
makes sense. And there is another question in the chat regarding performance.
Yeah, I'm looking
by Jonathan.
Well, I'm going to start with annotates first. It says, what if I wanted to do with just a Rhino Python script that is not hosted in GH? Would that work with this as well? Would it be more of a change so we're going to look at that right now. That's the very next thing we're going to do. So hopefully that will help answer that question. And then you wrote 10, would using hops and Rhino Compute run faster when compared to a cluster of components that would be doing the same thing? It's no faster. In fact, it might be a hair slower because you have to also calculate in the transit time of sending the data over to a server and then the transit time back, right? So it could be a hair slower using compute if it's just like a single instance, right? Because you're also adding in the amount of time it has to package up and send the request and get the response back and so on and so forth. So, but like I said, I think the where you get the real speed performance is the cache. So again, if you send it values that you've already processed, then, and especially on definitions that are quite large, then it doesn't have to redo the calculation. Whereas if you're running that remote or locally on desktop mode, let's say, every time you go back with the same configuration, it's still going to calculate the same thing, right? There's no cache in just a normal Grasshopper definition. And so with this method, if you have a definition that's quite large and you kind of pre-process some of that, that cache will speed up things incredibly. And then the second thing is, like I said, with the parallelization, if you're sending things with like item access and you pass it a list, it can now start parsing those requests out to all of the different children that you have and speed things up that way. The other thing I should mention, because I mentioned it at the top of the workshop, is that hops has if we right click on the hops component, you can say whether or not you want to run the call asynchronous. That is how you, so again, let's say we had a huge definition that we were loading up, and normally, you know, if we had that big spaghetti code definition, this one, right? If we were trying to run this, let's say it took 10 seconds to calculate and give me the result. Well, when I do that, if I ran this locally, my UI, my actual Grasshopper and Rhino would lock up until the 10 seconds were over and the Grasshopper definition. By setting this to asynchronous, so by right-clicking and setting asynchronous, now it tells Rhino not to lock up the UI while it's waiting for the request to come back. Does that make sense? And so that's another benefit, I think, of using hops over sort of a performance boost in some ways. Does that answer your question, Jonathan?
Yep, it does. Thank you.
Okay, the question was about the Python server, and we're going to step to that now. So one thing that I have already explained was that here we have a server, and I keep touching it. Here we have a server that is written in .NET. That's just an application, or that's just a framework that we can use to build a web server, okay? But you can create web servers in any number of languages. Python, you can create a Node.js server. There's lots of different ways you can create web servers, and we actually have examples of doing both a Node.js server and Python. And so the one we're going to look at right now is a Python server. So hopefully each of you received the email yesterday and downloaded Python, and you don't need Flash because we're going to do it, but hopefully you pulled down the repo at this address. If I go here, this is if you go to this link, this is where you can pull down the Rhino Compute server. And this is basically those two projects that I was talking about with Rhino Compute and Compute Geometry. So if you go under the source folder, there is the Rhino. All this is what is creating the application called Rhino Compute.exe. And then everything under Compute Geometry is what is being used for the Compute Geometry.exe. So that's where you find the code for those two projects. And that's why I was saying there's two projects. There's also this one called ghops server pi. And that's the one we're going to go into, which helps us understand how to know a little bit more about running a Python server. So if you have Visual Studio Code open, I'm going to close all those JSON files that I saved earlier and not save them. And I'll just close the folder. Let's see. And what you can do is go to File, Open Folder. And when you clone the repo, you cloned it to somewhere. When you did the git clone command, you cloned it somewhere on your computer. I have mine on my C drive under the dev, GitHub, McNeil, and then compute. So this is where I cloned my folder. So you can see that the folder structure here is the same as over here. So we see it's actually up here, right? So here I can see that I have VS Code, script, source, tools, compute gen, things like that. So that's all saved at that location. So what I want to do is go under source and then the ghops server and then examples. That's where I sort of want to get to in Visual Studio Code. So I'm going to go to source and then ghops server.py and then examples. So I just want to open that folder. And when I do, over here on the left, you'll see the files that are located in that folder. So you should see the same files that are in this. So you hear those examples, right? And these are just your Python files that help you, that are sort of boilerplate for setting up a Python server. Now, if you have, this is the first time you are running a Python server, you probably want to make sure we have all of the dependencies installed to be able to run the Python server. And if we go back over to our PowerPoint, you can see that there's this command over here that says pip, PIP, which is sort of the package manager for Python. And so we type in pip install and then ghops-server and Flask. So what that's going to tell Python or Visual Studio Code is to install these two modules. One is called ghops server and one is called Flask. And those are modules that we can run that will help us run our server. So here, if you don't already have a terminal up in Visual Studio Code, you can go to terminal, new terminal. But you should see your directory right here. And you can say pip install, was it ghops? Let me just make sure I get the spelling right. Yeah. So it's ghops server and then Flask. So it's pip install ghops-server and then space and then Flask and hit enter. And what that will do is run through and install the ghops server and the Flask modules. If you've already done it, you should see something, or if everything is already installed, you should see that it will say requirement already satisfied. So you can see that the ghops server actually has some other dependencies like the Rhino 3DM and some of these other ones, Jinja 2 and things like that. So it does have some other modules that it ends up installing as well. But the only two we really need are these two, and then it will install the other sub-dependencies that it needs. Once we do that, we can then go and click on the app.py file that is found under the examples folder. Now, you could write this from scratch if you wanted, but because we're running already a little bit low on time, I don't want to spend all that time writing this code when it's already there. What I'd like to do is just kind of go through the code and kind of highlight a couple points. So one of the things you can see right up here at the top is that we're going to be importing the ghops server, and we're going to be calling it HS, just as an example, for hops server. And then we're also importing Rhino 3DM as a module, so we can call some Rhino 3DM functions. And there's also Flask. Here, we're essentially creating the hops server and the Flask server. And then what we want to do is define some endpoints, right? So these endpoints are what Flask ends up using to route the essentially the request to the right place, right? So let's look at this one called add. So if you scroll down a little bit, you'll start to see these ones that have an @ symbol, and then it says hops and then component. And this is just defining a Python function which tells the hop server how to respond to a request when it's called here. So you remember earlier I had a request that said something like, right, it was something like HTTP localhost, and then the port number, and then we had IO, or we had Grasshopper. Well, that last little bit is what we call an endpoint, the dash and IO, or the dash and Grasshopper, or / sorry. And so what we're doing here is defining some endpoints that can be hit when we run the server. And so in this case, when we send the endpoint add, it knows to route the request to this section of code and to do something, right? So the first step is the part that helps define the component. It's basically the IO version, right? Which is saying like how to define the inputs and outputs. So here you can define inputs as a hops number. One's called A, one's called B, and the output is going to be a number, and it's going to be called sum, right? So this is just this is basically like setting up the IO version when it gets hit with this method. And then here is what's going to happen when this method gets called. It's sort of the Grasshopper part. Like when I give it the values of A and B, return the value of A plus B, right? Let's look at a different example. Here we have a endpoint called point at, right? So we have, when we call this, we're basically saying we find a point at a position on a curve, right? So you can see get a point along a curve. And the endpoint is called point at. This is just telling it like the name of the component should be called point at. The nickname is that. It's going to give it a description. It's even going to give it an icon. So I glossed over a couple things that I meant to mention about the hops, which I'll talk about in just a second. But you can give things icons. So here there is a PNG file also located in our examples folder. And so it's saying, go and locate that PNG file and use that icon for the component. Then we're going to pass it in a curve and a number, and we're going to get it a point out. And what is going to happen when I actually pass it the values, like the curve and the t value, is it's going to call this Rhino 3DM function. So remember, we imported the Rhino 3DM. And so we can say curve.pointAt and pass it a numeric value, and that will then return a point. Does that make sense? All this is to say, this is kind of a boilerplate for creating Python functions that can be used with hops. So basically this very first part, like everything from line 15 up, is kind of standard. And then everything else are essentially methods that you can define for yourself. Like you can say, I want a component that finds the point on a curve, or I want a component that creates a surface from 4 points, right? And this shows you how to do that. So you can essentially create any number of methods. And the nice thing about Python, those of you who use it a lot, I don't happen to use it a lot, but there are a lot of Python libraries out there that can also now work with this. So you could have a machine learning library that you import, and then you pass the data from here, you then do some machine learning, and then you pass the data back, right? So there's a lot of things that can be done here that are kind of interesting. But so what I need to do now that I've installed all of my modules is I want to run Python app.py, right? So we're inside this folder. It knows where app.py is. And all I'm saying is run the Python executable and call the app.py file. And when I do, it's going to start loading Flask and some other things. But now the key part here is that there is this URL that says HTTP 127.0.0.1 and then colon 5000. Now that URL, this part, the 127.0.0.1 is the exact same thing as localhost. So whereas the other server over here said listening on localhost 6500, the only thing that's different is that localhost is the exact same as that URL. So this is just listening on port 5000 and the other one is listening on port 6500. Does that make sense to everybody? So now we're setting up two servers that are going to be listening at the same time, right? So I've got one .NET server that is listening on port 6500, and now I have a server that's listening, a Python server that's listening at port 5000. So now that it's running, I'm just going to copy and paste. I'll select that whole line all the way to the endpoint. And let's go to a new file. And I'm going to have a hops component. And now I can double click on it and it says set a URL or a path. In this case, instead of setting a local path, I want to set the URL to our server, right? So I want to set this to be this. And now I have to add that endpoint, right? So this is just going to hit the entire server. I need to tell it specifically to go not to just the server, but go and call this particular function, right? The point at function. So, you know, you can copy it or just type it in, but let's say we wanted point at. So our whole address should look like http://127.0.0.1:5000/point at. And that is a mouthful. But if we click OK, you can see what happened is it sent a request over to my Python server. And you should also see that here is the request that it received. Just like in the console window, we should start to see, and actually I should try to minimize this. So here you can see that what happened is it sent the request over. It was a GET request to the endpoint called point at, and it sent a 200 request message, right? So that means good. And you know that it worked because it loaded the icon. I mean, it loaded everything, right? I have a C input and a T input and a P output, right? Those come from right here, right? Those values are coming from the nickname of the inputs and outputs that I have defined. If I were to display the full name, nope, that's interesting. It should, I thought it would show the full name, but I guess maybe not. So now what it's looking, it hasn't done anything. It's only done the sort of IO part. It hasn't actually found a curve. So let's create a curve in our scene. And so I'm going to go to geometry and curve. And let me first actually draw a curve. And right click and say set one curve. And I will pass this into the C input. And then I need a value to for my T input. So here you can see that now I'm getting a point down here on my curve. Now, who can tell me why it isn't going all the way along the curve?
Yes, it's the parameter of the curve. It needs to be, yeah, it goes from 0 to something else.
That's absolutely right. So the curve domain isn't from 0 to 1. It's probably 0 to 20 or 30 or whatever. But the key here is I can right click on this C input and say reparameterize. And now it will take that domain and map it from 0 to 1. So 1 will be all the way at the end and 0 is all the way at the beginning. And you can see every time I'm hitting that slider that that it's sending a request, and so you see those messages showing up on my console. Does everybody see that? And so now you can see that I'm hitting a Python server and getting the result back, which is, you know, processing right here. You can hit any number of servers at the same time, right? Let me open. I'm going to open a document from our workshop files because it's here, which is this one. Is this going to work? Yeah. let's see. There we go. So, all right, what's happening now? So I've got this one, which is the same component we just looked at, right? Which is the point on. And so you can see when I'm moving the slider, it's hitting that slider and finding a point on a curve. Does everybody see that? So I've got a curve here and it is finding a point on a curve. Now I did have to reparameterize that. So that looks like a bug that it doesn't serialize that setting. So I need to, you have to set reparameterize so that it knows to go the full distance. But then I'm created another hops component, which is loading this file. So if I go and open this number 11, all this is doing is like getting a curve, getting the number of cells and getting a point, and then essentially performing a Voronoi grid division. And so what we're doing is this one is hitting the Python server and this one is hitting the .NET server, right? That's this one. So if I kind of pull this, I've got too many things in line, but you should be able to see that this one is my Python server and this one is my .NET server, and they're both going to be in the same definition. Does that make sense to everybody? So you can actually have one definition hitting one server, another one hitting another server. And really, I've already kind of missed my opportunity here, which is how do we begin to simplify the distribution of some of this stuff for other people? There's a question about, do you see speed difference? Not really, to my knowledge. I haven't done any benchmarking tests about speed differences between the two, but I have not seen any differences between the two servers because they're basically running the same general code base. There is one thing I wanted to show, which is this. If we go back over to our preferences, is this thing called hops function sources. And there's this add source, which lets us specify a path or a URL to a collection of functions that we want to use frequently, right? So let's say we wanted to create a local folder path. So we could go to the workshop files that we were working on and select this folder and say, we'll call this workshop files and click OK. And then let's say we want, so now, and then I close this. Now, when I load any hops component, I can right click on this. And if I have, as long as I have one valid function source, right? As long as I go to preferences and there's one valid source here, again, you can edit it if you need to. But if I close that down, I should see available functions here. So I can right click on this and say available functions. And this is going to let me, it's essentially going to go into that folder and create a menu list of all of the files that are in that folder, right? And give you a little thumbnail. So here is that all of those different folder files. So if I wanted to very quickly, you can right click and it will actually open the file, or left click. And when I left click, it essentially creates a hops component that has already set the path to that particular file. Does that make sense? So this is a way to very quickly get at, be able to get a lot of access to a lot of quick functions. So you could set this to a network path where you and your colleagues are storing all of your functions. And now you can very quickly have everyone point to that same directory. Secondly is you could also go back to the preferences and add a path to our Python server. So if I go back up, well, now it's at the very top, it might not even be there anymore. If I go back up to the top and I set another source, and let's set the URL to HTTP, it was 127.0.0.1, 5000, and then /. And we can call this our Python server, right? And I can click OK. Now, and click and close that. I'll just get rid of this and add another hops component. And when I do, it'll say available functions. Only this time I've got two nodes, right? I've got my workshop files, which knows to look at local files. I've got the Python server, and there are my 4 methods that were defined in my Python server, right? So this is a way to quickly enumerate, if you follow this same boilerplate example, is a simple way to enumerate all of your Python functions. So here I could do the point at, and now the path is set here as 127.5000 point at, right? And so that is another way to easily locate. And then I'll show one last one, which is if we have this on our server. This is also available open source. It's called the app server. So if you were to go to this URL, I can put this in the chat. And you can go to examples. Under here, it says example, and you can actually click on this. And this shows you some different examples that are available. So for example, what this is doing is loading up a Grasshopper file on the app server, but it's hitting a remote server. So remember how we were talking about there is like you can hit a remote server. And it looks like it might be taking a while, but it's possible what happened is that server is doing what we saw. It's essentially spinning up those children, if that makes sense. So you notice it takes a little while to launch all of the children. And then once the children are launched, it can perform the calculation fairly quickly. And so what we can do is give it this URL. If I right click and go here, I'll just do this URL. And if I go back to my function sources, I'll add another source and give it that path. And I will call this remote server and click OK. And now I can close that. And now I have another list of available functions. And it's not working because that that server might not be up and running. So there's a chance that okay, there we go. So here's where you can actually you can see like it's actually performing some calculations. So with these sliders, it's doing, this is a web app that is passing a request to a remote server and visualizing the information. So now what I should be able to do, now that I know that that server is working, is, and maybe it didn't need the examples, that might be the problem. I think it's just this as the URL. Yeah. So now I can hit a remote server, and it got this list by polling that remote server. And if I select this one in particular, this is like a tractor point definition. So here I'm going to pass in this point on our curve, and it's a little slow. I'll turn the preview off on this so we don't see it anymore. And I can use the display to color the panels. But what you're seeing now is it's going to get the point on a curve, which is calling the Python server. It's then taking that point and going and sending a remote request, right, to a server that's somewhere in the cloud, and then getting the results back. So here, if I change the position, it gets a little bit slower, but you can see that it's, solving the definition remotely, well, locally and remotely. So you can actually begin to take some of these parts of your definition and parse out the parts that are fairly memory intensive and may require, different functions. Like you might have a part that needs machine learning, which is only available in a Python library. So you might send a Python request, but then the rest are running locally. So there's any number of ways, if you know how and where you're sending your requests. Are there any questions? It's a lot to take in, isn't it? I forgot one very important thing when I was talking. I wanted to cover two other things. I'm going to go back and open that Hello World example. It's number 6. So this is that very first one we talked about. And this is one that you may have noticed that all of the hops components have these little hops leaf, little hops leaf on it. And that's the default icon that gets used for any hops component. But you can actually create your own icons for these hops components. And the way you do it is you have your definition and you go to File, Document, Properties, and you can set your icon right here. So there's some document properties, and I'm going to set the icon. And I've created a couple here. There's one called Hello World, but there's also some for the other examples that are in that folder. These are basically the same as that initial example that had the quad panel. So you can actually break that file into smaller functions and assign their own images or icons. You can load a PNG or an SVG. I think we're pushing people more towards SVG because they will end up being rendered a little bit cleaner, especially on high definition displays. So I'm just going to load the Hello World SVG and click OK, and then save the document. And next time when I say new, I am going to add the hops component and load that path. So again, this is in my workshop files under Hello World, and click OK. And now you can see that instead of the hops icon, it's a icon right here, right? It's whatever value you wanted to, or image you wanted to use. Does that make sense to everybody? I wanted to show one other way to be able to distribute and have these easily accessible to people, to other people, right? So I already showed about adding the function sources, right? Which is here. So you can easily access files that are, frequently used. But let's say you wanted to, how could you create a toolbar that uses these components? And we've thought about different ways, but it turns out there's already an existing way we could do this. And that's using user objects. So if you select a single component, right, you can only select one component for this to work. But if it's a hops component, it's essentially loading an external definition. We can set this up and say, create user object. And here, this is going to ask me for a number of properties, like what is the name of the component? In this case, let's call it Hello World. The name is going to be HW, or the nickname, that's a shorter name, we can just call it HW. And we can give it a description, say hello to me. And now you can specify the category and subcategory. So the category is which tab do you want this to be saved in, and then which subcategory is like the group, right? So if you wanted to put it in the params util, it would say params and util here. You can also set the exposure. In this case, whether you want to hide it or not, or which exposure level. So you'll notice that some of these categories have a little vertical separator. So this is the first exposure level, and this is the second, and then this is the third, and it goes up to 8, I think. So there's 8 different exposure levels that you can determine. So if you want it to be, some of your components to be in the first exposure level, and then some to be in the second, and some to be in the third, you can set that here. You can even change the icon. So you could set, your icon here. In this case, it's already picked up on the icon. You can actually, it's hard to see, but you can see it tries to create some variations for you. Or you can actually use by default some of the existing icons. So this is a list of all the icons that are currently on your machine. Or you can browse for one. So I'm just going to click OK. And now it's created a new hops tab under the functions subcategory, and there is one called Hello World. And when I add this out, you can see it's already defined the hops function and the path to go locate that. And then, so now you can send this user object to somebody. So here, if we go to File, Special Folders, and go to the User Objects folder, you can see that it has created a file in my roaming Grasshopper user objects folder called helloworld.ghuser. You can send that to someone and they can drag and drop this onto their Grasshopper canvas. And now they will also have this component. Now, something to note. If they have that, their path, it's going to set the path to wherever the path was set here. So obviously, if they don't have the same folder structure as you do, it's not going to work. Now, is there a workaround for that? There is. So if I go back to, let's see, let me create a new hops folder, a new hops component, and I'm going to set it back to that hello world here. And if I right click on this, you'll notice that there's one called internalized definition. Now this really only works for files, local files, but just like you internalize a curve, right? If I reference this curve in right now and I save the definition, this doesn't actually save the curve with my Grasshopper definition. It saves a reference to my curve. And so you have to have the Rhino file with the curve also saved in order for this to load the next time you open it. If you right click on it though and internalize the data, then it will save the curve with the Grasshopper file, and now you no longer have to have the Rhino file. So the same idea is true with this. If I right click and say internalize definition, it now forgets, it no longer has a path set. The path is empty because what it's done is save that definition as part of the hops component. So now if I save, this, I can say file, create user object, and let's call this hello world 2. And we'll call this HW2, and we'll just say, okay. Now there is another component here called hello world 2, and if I drag this out, it should still work. Let's give it a name, even if it doesn't have the same file. So we'll say Steve. And there, you can see that it's created, like it solved it, even though it doesn't have a path set. And the reason it's doing that is because it's internalized that hello world definition into this file, into the user object. Does that make sense to everybody?
Yeah, I think it does. A question related to that. If you don't internalize it and you have that link, does that mean that you can update the Grasshopper definition on the other end? Let's say you do a bug fix or something. Can that be a way of kind of handling versions of a Grasshopper definition?
Absolutely, absolutely, and that's the benefit. That's one of the benefits of hops over a cluster. A cluster saves the cluster in the Grasshopper file. It's not really an external file that you can manage. Hops is using an external Grasshopper file. So this could be stored in some sort of local repository, and then you can update it as much as you want. And next time the person opens the file, it's going to go and load that particular file and give you the proper result. So that's exactly the benefit here, and also why it's somewhat useful to use the source, right? If you have this as like your on a network drive that everybody has access to, then every time people can just simply load your available function from your local or your network drive and have the latest file. What other questions? That was a lot to cover. But the real key, I think, for me, again, what I would like you to understand is this relationship. We went into a lot of technical detail, but for me, the key here is this line, is knowing that there is essentially two different applications, and one is simply sending a request to the server, and the server is responding back. But they are two separate things. One is a client and one is a server. And if you can walk away with understanding how that works, then that's great. Whether you know how to set up a Python server or anything like that, or you can go through and follow this video again, or go through the PowerPoint presentation and look for that to go through that in more detail. But really understanding how it's sending and receiving JSON requests and responses, that's really the key here. Now, I wanted to show, if you don't mind, we have about, I know we're at our limit, but there's one other thing that we haven't covered that I'd still like to cover, which is the script compiler. And so what I'd like to do is, first, I'm going to go to our workshop files folder. And let's say, so what the script compiler does is it's a way to package up Grasshopper files into a plugin that you can either share with your colleagues or distribute through the package manager. So you guys all saw that when I type in over here, the package manager, that there is a package manager that I can install any number of third-party plugins, right? Well, I am going to show you how you can create your own plugin here that you can distribute over here. Now, some of these are specifically for Grasshopper, and the plugin we're going to show is actually more for the Grasshopper Player command. But I'll show you how the script compiler works. In order to do that, before we start, I want to go back to my workshop files folder, and let's just say I wanted to call this tower and the quad panel one, right? So we showed the quad panel and the twisty tower for Grasshopper Player. So I can say copy those, and I'm going to go back to my desktop, and let's just say we're going to create a new folder called script compiler. You could have made this in the same folder, but I'm going to create a separate folder, right, for this plugin. So I now have a folder called script compiler on my desktop with these two files. I'm going to go ahead and shut Grasshopper down and just load Rhino now. And under the Rhino tools, you'll see that there is a menu item called script compiler. If I click on that, it will launch an executable called the Rhino script compiler. And this is a very menu driven, there's no real clicks and stuff like that. It's all done through a menu options using these blue letters. So if you want to create a new project, you type N. If you wanted to open an existing one, you type O. So same, all you need, those are how you actually end up traversing this menu. So for us, because this is a new plugin that we're developing, I'm going to type N, and it asks me for a project name. So let's call this my Grasshopper Player plugin. You could be more concise, hopefully, than I can. And I'll say that. And now it's going to ask me, where do you want to save this RHC file? This is basically the script compiler settings file. So again, I'm going to save it in the same folder. It's kind of important. It will fail if it's not the same folder. It needs to be the same folder that we stored those Grasshopper files. So I'm going to save it in that desktop script compiler folder. Now, once we do that, it gives us some information up here as well as some options. So we're in our project set. We already have loaded my Grasshopper Player plugin. Let's type A and edit the author settings. So I hit A, and now it's going to say, who's the author of this particular plugin? So I'll hit N, and it says author name. So I'll type my name. And now you can see that the name has been set to Andy Payne. I can set E and say andy.payne@mcneil.com. I can say C and set the country as USA. You get the idea. When you're done, you can just hit enter again, and it will go back to the main menu. So we've now set the author, and you can also see that some of those settings are up here, right? The contact and author and address are all set up here. the next thing we can do is set the plugin setting. So I can hit P. And this is where you can set the version number. Again, for us, I'll just keep it at 0.1, but let's say you created one and then you distributed it and now you want to distribute an update. You could update this to 0.1.1 or something, 0.2. So you can set the version number by hitting B. You could change the name if you wanted. The output in this case is it's going to create a folder called bin in the same folder, that script compiler folder we created. And so I'm just going to leave everything else there. But again, you could also set the minimum Rhino version if you wanted. So I'm not really going to change anything here. I just wanted to open it and show you what some of these settings are. So I'll hit enter to go back to the main menu. And now I'm going to hit C for the command setting. And this is where it's asking you to load the Grasshopper scripts that you want to use in the command line. So here, I'll just load those 2 files that we created earlier and hit OK. And when you do, it now shows that I have 2 files that are going to be run as a command. And so if I want to edit in either of those, it says enter the index of the command to edit. So I'll go into the first one and I'll say 1 and then hit enter. And you can see that it's located this file and it's also given it a name and a command. Well, this is the name that you would type into the command line to call this Grasshopper file. And to me, that's super long and annoying and nobody wants to type in O3 quad panel, whatever. So you might say in, and I'll just name this create quads or quad panels. I don't know. And so now the user would only have to type this in or start typing this in for it to load this file. I'll hit enter to go back and I'll do the same thing for the other file. Now I'm going to hit name and I'll just call this Twisty Tower. So if you call that in the command line, it will now call that and I'll hit enter again. I'll hit enter one more time to go back to the main menu. And now that I've defined the commands that I want to call and all the other preferences, I can hit B for build the current project. And I'll hit B and hopefully if everything went well, everything will turn green and it will say that it built everything. And you can hit any key to continue. If I go back over to this folder, you can see that it has now created a bin folder, and here is my plugin RHP file, as well as my YAC file. So a plugin, this RHP file is a plugin file that I can drag and drop right over here onto my Rhino file, which I'll do in a second, and that will let me now load the plugin and call those 2 commands. This is a YAC file, and if you go back to your PowerPoint, there at the end is a website. If you hold control, should open this. And this is a link to a guide that is set up to explain exactly how you push a package to the server. And when you do this, go through this process, you will then be able to find it in the package manager, right? So once you've pushed that YAC file onto the package manager, you can then get that here. And so this is another way of compiling all of your Grasshopper files into a plugin that you can share with your colleagues by sending them this RHP file or loading it to the package manager and just letting people download it from the package manager, right? You can even have your own private package manager, but that's a whole different guide and topic. So let me go back and drag and drop the RHP file over here onto it. And you can see it says drag and drop loaded plugin. And now I should be able to say create quad panels. And when I do, it's asking me to set the height. I can hit 6. And you can see now it's stepping through and calling that file, right? I can just keep hitting there. And now it's created using the defaults. It's created our panel. If I do the other one, I think it'll work. If I type in Twisty Tower, yep, there's our tower that is now a plugin command that all you have to do is call Twisty Tower. You don't have to call Grasshopper Player and locate the file and things like that. You just have to call that one command and it will load it every time. So this is another way that's really useful, I think, for distributing files. So we've talked about sharing Grasshopper user objects. We've talked about compiling it to a plugin, publishing it to the Yak, or publishing the Yak file to the package manager, and setting function sources. So those are all different ways, I think, that are pretty useful for ways to navigate Rhino and Grasshopper and be able to access these different functions. Were there any questions about the script compiler or really in general, anything that we covered today?
If you make some changes to the script compiler, can you just simply drag the new file and then you will overwrite the previous one?
It's a great question. I have never actually tried doing. So I think what you would do is you would save this. So you hit S to save the current project. You'll just save this, here. And then so we could close this, right? Let's say you've made some changes now, it's 2 weeks later. You go back to the script compiler and you would say, open an existing project. In this case, we're going to open this one. We're going to go back to the command settings. And this is where you would go in and either add a new command or go back to number 2, right? And let's say, and then hit F and you would locate a new file. And then save it and build it and things like that, right? You would then hit that. Yeah, so now it's unset, so I don't want to do that. But you would go back to here and hit build. This would not work because I unset the file, but if you had located a new file and hit build. Now, like I said, the thing to remember is to also remember to have the file in the same place as your RHC. I have done this workshop a couple of times and accidentally not had the file in the same folder as the RHC file, and the build does not work, and then you look like not a smart person. So it is key to to make sure that the file is also located in the same folder. That's probably a bug we should fix, but this is, that's one way to actually update it. And then you would also want to update the plugin settings, right? You would go here and set the version to be like 0.1.1, right? So the next time you build it, it's going to have a new version number.
Thanks.
What else?
Hey, Andy, is the script compiler CLI available outside of Rhino to download and use programmatically?
No idea. I didn't write this. I would probably direct that to either Will or Steve, who are other developers who I know could answer your question. My hunch is that yes, it probably could be run externally. I mean, it's just running an executable. You can see it's even its own executable. So I'm sure if we were to search for like Rhino script compiler, it's somewhere located in your Rhino. Looks like somebody even posted a link here. Well, there you go.
Perfect. Yeah, it seems like that would be very useful to like pull down in a CI/CD pipeline to like build, your artifacts.
Yeah. So yeah, I think you could do it here as well, or find it if you've already got Rhino loaded. It's probably also installed when you installed Rhino. So you just need to find where the executable is, and you could launch it that way.
Awesome.
What else? I know that was a lot to take in, and there were definitely some technical parts that probably weren't always the most entertaining to listen to. But if you stuck with me for 3 hours, then hats off to you, and hopefully you learned a little bit.
And can I ask one more question?
Sure.
I'm just wondering about kind of the implications of like stringing together asynchronous components in a Grasshopper definition. I'm wondering, for example, if you have like multiple asynchronous components feeding into another one, if the default behavior is to kind of like wait for all of them, the response to come back for all of them before, computing the next kind of thing in line. And also, if there's any sort of like features or patterns to kind of handle like fallback behavior if a response fails, but you don't want your whole script to fail.
Probably the short answer is there isn't probably a great fallback mechanism, only because we're still developing this, but it's sort of split between a number of different developers, including myself. So I've been the one who's mostly been manning the development of this since I joined last October, meaning Hops and Compute. But I'm also splitting time with other projects that I'm working on. And so unfortunately, that means we don't have, we just haven't gotten to all of the feature requests that a lot of people have asked for. Obviously, we need to there are a number of things that we could do to improve the overall user usability of the product to make it even easier to use. Debugging information, like adding more debugging information to the console so you know when things are breaking and what's happening. And adding persistent data storage for the cache and things like that. We have a long roadmap of things that we definitely want to include. It's just we have not gotten to all of those items. As far as your asynchronous question, I haven't personally tested that. I would love to know it if you do, but it should, I think, wait. So if you run it asynchronous, the next component will wait until the upstream gets its data, right? So what I mean by that is, the visual graph only computes as fast as the inputs are coming in, right? So if you've got a component up here and you've got 3 components that are feeding it, this one, the downstream one, won't solve until it's got all of its inputs satisfied, right? So if you've got one that is running asynchronous but still hasn't gotten the result yet, the one downstream won't update until all of those inputs are satisfied and then run, right? And so again, without having tested it, that's my assumption of how that would work. So it should wait until the values come in and then process that, and then the next one will feed downstream and so on and so forth. So that part should work. Okay, well, I don't want to keep anybody any longer than we already have. I know it's a little bit later than we thought, so I apologize I apologize for that. But thank you all for those who stayed. And as always, feel free to email me if you have any questions, or you can post in the Slack channel as well, and I will do my best to answer any follow-up questions.
Well, we're in there.
Awesome. Thanks a lot, Danny. Really good workshop.
Great.
Yeah, thank you very much.
All right. Well, thank you guys for staying long. I appreciate it.
Thanks. See you.
Okay. Bye-bye.